Guys, welcome back. I guess I should say welcome back to Joel does biochem, right? Okay, so we're gonna do biochem. So this is chapter 1.1, amino acids found in proteins. Now, I went over amino acids already in the orgo section, so this video is going to just be like 1 minute long. We're just gonna go over some key amino acids and then we'll go through this chart really quickly. Well, a little longer than 1 minute, but let's just get started. So first you need to know if amino acids have this general structure of a nitro group connected to a nitro group connected to a CH group connected to an R group connected to a carboxylic acid. Okay. The only thing that changes about this structure is this part. So the structure will always be exactly what it is here. Okay, it would be this exact group, but you can draw it like multiple different ways, meaning that like you could have it in Fisher projection, right? So like that's the same thing as this. You could put it in bond line, which I really like to do, but my teacher hated it. So you could do something like NH2, C, R, H, C, O, O, H. Okay, you could also draw it like that. So just get used to seeing it every which way. And again, the only thing that changes is the R group. Everything else stays the same. So next, so your amino acid really isn't ever going to be found in this form. So physiological pH is going to be roughly 7.4. The pK of this is roughly 2.18. pK of this is roughly, forgive me, I think it's 9.5 about. 8.5, sorry, 9.5. Okay, so pretty much what this means is 99.9% of the time you are going to find your amino acid in what we call the Zeneret form. The Zeneret, I always get it wrong, but pretty much this is always going to grab that pKa due to it being that hydrogen due to it being really reactive. Okay, so then we would get something along the lines of NH3 plus. You get your R group here, O minus, double one O. And this is the state that you're going to find your amino acid in most times. By most, I quite literally mean always, because most times, you're always going to be at 7.4 pH. Okay? So, we need to go over this. So, all amino acids are almost L. Almost all amino acids are L and R. L meaning the amino group is on the left. Sorry, I drew this. This should be on the right. So, you guys see, now you know. Right is D, left is L. Okay. And I say almost all because one, glycine isn't chiral. Okay. So glycine doesn't have an R and S or a D and L due to it not being chiral. And what I mean when I say chiral, I mean this carbon isn't connected to four different things because it's connected to these two. And these two are the same when it comes to priority groups. If that doesn't sound familiar, you should go back and watch the Orgo video on priority groups. So due to that, this isn't chiral. Cysteine is the only amino acid that is going to be LNS. So cysteine, LNS, and that's due to this diol group. So again, this goes back to priority because cysteine has this diol group. It's going to change the stereochemistry. And that's all you need to know about that. And again, like I said before, you can see amino acids in this form. So now we're just gonna quickly talk through amino acids. I mean, again, I can't really help with the memorization, but I can tell you what you need to memorize. So you should know that, right? So you should know which ones are uncharged, hydrophobic, nonpolar. You need to know which ones are charged. You need to know all your basic ones. You need to know your special ones, and well, actually, these you actually don't. Like in terms of like this, you're not going to see a lot. I mean, if you're going for the 528 though, you're going for the 528, yeah, you should know that. But other than that, like that's not too important. And you should know which ones are electrically charged and which ones are polar. Um, you don't really need to know the pKs exactly, but you should really get a rough estimate on like what how acidic that all of these are, because then that's going to change the reactivity. So thank you guys for stopping by the first video of Biochem, and we'll see you in chapter 2, acid base.